So this problem starts off with the median home price in Little Rock in 1990 was $45,000 and has increased by 2.5% each year. Which function models the median annual home price, P of X, for Little Rock X years after 1990? So this is changing by a percentage. So that tells me that this is an exponential function and the price is increasing, so this is exponential growth. So what you want to use, get my pen here, what we want to use is this form of an exponential, so a times 1 plus the rate and to the x power. And so this is what you want to use for growth. And I'll just show you what you want to use if it was decay, meaning it was decreasing. So for decay, it would be very similar. Y equals A times 1 minus the rate to the x power. And so that would give you decay. So the A in here stands for the initial value. So A, let me pick a different color here. A is the initial value. It's what it starts at. In this case, that's going to be the $45,000. That's what the price starts at. So the initial value, R is the rate, and that needs to be as a decimal. Rate as a decimal, not as a percent. So if you're given a percent, you have to divide it by 100. So in our case, our A value is going to be the 45,000. I forgot to put the E on value. That's why I teach math. So I have the $45,000. That's the initial value of the home. And then the rate written as a decimal, you would do 2.5 divided by 100. So you would get 0.025. All right, so there's my rate. So if I plug those in to the equation for growth that we talked about, what you'll end up with, and so we'll use P of X instead of Y. So here we go, P of X equals the initial value, which is 45,000. 45,000 and it's growth, so it's 1 plus the rate. And for the rate, again, we're going to use the 0.025. And we got that by dividing the 2.5% by 100. And so there's what our answer looks like, and that corresponds with answer C. So make sure you understand exponential functions. They're an important part of algebra. Keep it up, and you will master the math.